And here's another problem in which we can use the equations of motion for rotary motion. And this one says, how many revolutions does it take for a wheel to accelerate from rest to 3,500 RPM over a 22.4 second time period? So let's write down what we know so we can pick out an equation from our list. So we've got, for this one, an initial velocity of omega 0 of 0, and omega f, a final velocity of 3,500 revolutions per minute. We've got a time, a delta t, of 22.4 seconds, and we are trying to find how many revolutions that will be a delta theta. That's what we're looking for. I recognize right away I need to do the conversion of this, so that will be 2 pi radians per revolution, and 1 minute over 60 seconds. And that works out to be, I would take some time and do it myself, I get 367 radians per second. All right, so looking at what I know in this problem, I've got an omega f and omega I, sorry, I made it omega 0 for some reason. Let's fix that. It's omega I. I was probably thinking about omega being 0. And let's see, I think probably the equation we want to go with would be the one that goes like this. The delta theta is omega f plus omega I over 2, the quantity times delta t, which is essentially calculated an average velocity. So omega f is, we just figured out 367 radians per second plus 0, all divided by 2, and that times 22.4 seconds. Again, I would invite you to pause, plug the numbers in yourself. When I do this, I get 4,110, and that will come out in radians. If you look at the units, you'll see that the seconds will cancel out. We'll end up in radians. We can't leave it in radians because the question asks for revolutions. So we can do that pretty easily. Let's just go ahead and do a unit conversion here. We need to multiply times revolution is 2 pi radians. So essentially dividing that by 2 pi gives you, I get 654 revolutions. Okay, so I would again invite you to check all my math and make sure it's right. But here we have a displacement problem given an initial final velocity and a time.